I remember.
Okay, so let's do the bit. Let's do. So now we got 2 is in S, right?
Yes.
Let's do
The size.
Oh, that's for something else. Yeah. Let's do when what happens once you got 2 is in S, right?
Okay, what happens when
What the
2 is in S?
So
Like,
yeah.
L minus 1 is in S. Wait, what?
So suppose you have 2 is in S, right?
yes.
And suppose you have 2L minus 1 is in S. Yeah.
Yes.
Okay. And then my claim is anytime you have a K that's in S, K plus 1 is in S. Yeah.
Oh, okay, less than 2.
So anytime you have a K that's less than 2L plus 1, 2L minus 1, then K plus 1 is in S.
Basically, you can get
Wait,
everything
so
less than
incredibly
2.
bad.
Yeah, so if you can get 2 to the L minus 1 arbitrarily large,
Yeah.
you can get everything.
Oh.
Oh.
Yeah.
And what's the proof?
Yeah.
Okay.
Yeah.
I don't know, did I omit the proof?
It is trivial.
I thought I actually wrote this proof though. Okay, so the proof basically goes like this.
What happened to the proof?
What
What happened to it?
Yeah, how do you tell you
Oh,
How
man.
did like slam each other?
Really?
Yeah, so basically, so clearly 2 to the L is in S, right? Or 2 to any power of 2 is in S.
He knows it's not anyway.
What?
Yeah.
Did I shuffle it? What the hell? What the hell?
Did I?
What? Okay, let me.
So then you have so you take K, right?
Okay, what the hell?
K
Well, why is he holding?
times
Okay.
K.
Originally, the top card is the power anyway.
7 of spades.
Okay.
Right, I shuffle it like this. That's still gonna be the top card.
Okay, so if you look at this fraction here,
Hey, you just can't front.
Hey,
Can't
it's
pretty.
so-
Like,
Oh, that's actually pretty
wait,
smart.
how many rainbows versus like there? What do you mean, how many rainbows?
Oh, that's. Wait.
so if you look at this fraction here, right?
I don't know.
You can't even double.
Oh wait, so you can get the gap between them to be arbitrarily small, which means that
It's
it's gonna be the next number.
Yeah, so K times
Okay.
K times this thing here, right?
Yeah.
It's obviously bigger than K, right?
Yeah.
Okay, but
Yeah.
is it less than or equal to k plus 1?
No one even says it.
It's obviously bigger than K, right?
If you make L as large as you
That's like
can,
missed opportunity.
then it
So then-
eventually works.
So then this thing here,
It's too big.
we can just do this I want to call this the high school trick because this got me through all. You just do the 2L minus 1 trick, yeah?
Yeah.
So you get K
Oh.
plus
Oh, plus k minus k.
K on
As your masters.
2L minus 1. Yeah?
No way!
Wait, hold up.
Oh,
That's
genius!
Sure. Yeah, that's what we did though. Isn't that what why is this plus 0?
Oh wait, no, yeah, of course. This is
Plus
the
k minus k.
This is just the
Okay, well,
fractions.
now this is big brain.
That's less than K plus 1, right?
Yes.
Yeah.
Classic.
No
classic.
So if you
way.
take the ceiling of that,
Oh, and it's K plus 1. No
Yeah.
way! Genius!
Congratulations. Nice. But how do you know? Okay, how do you get 2 to the L minus 1 then?
Yeah, that's true.
That's a little bit.
That's a good question.
That's a little bit difficult.
What?
Yeah.
Send in the landing.
Oh,
Oh, let's do what we do.
I got killed.
That was bad.
Oh, not very yet. We was leaving. We was leaving 2 layers, like one
Oh,
person
yeah.
and then another person on top of them.
Yeah,
so people don't
I
really know
got,
When was he?
I was just
1734 something.
Oh.
stable.
Oh, you're
closer.
You were close, yeah.
Every time.
okay, so this might be somewhat backwards, okay? So
Jerry, get your girlfriend out of
so
here.
if you can get 2L minus 1, yeah, then you can get another 2L minus 1 that's bigger. So you can so
I get the five.
do you believe, so if you get 2L minus 1 with a little L, you can get 2L minus 1 with a bigger L.
Yeah.
A big L.
Okay.
Okay.
Big L. Wow. Whatever.
I mean the idea is pretty simple. It's just
L.
but like
More than,
it might be a little bit
more than equal to
tricky with the small L's, yeah. If it's L's too small, it might be a bit annoying. But basically the idea is so if you can get a 2L minus 1, right? For a small L, then you can get what am I doing here? So the basic idea is you can get a 2L plus 1. You can get a 2L if you get 2L minus 1, you can get 2L plus 1 for all the smaller L's. So basically, so let me explain the idea before I read the proof. Okay, so basically, if you have, let's assume L is reasonably large for convenience, yeah, already. So basically, because you have this thing and you have the previous lemma, you get all these k plus 1s, right?
Yeah.
So you can let k be a power of 2, and you get the power of 2 plus 1s.
Yeah.
Does that make sense? So you get 2 to the L plus 1
You get all the numbers
below it, yeah. You get all the ones below it, yeah. So including 3, yeah. But 3 also happens to be 2 squared minus 1, right?
Yeah, so we got 3. Okay,
So-
now we
so-
got 3.
So I don't know. I don't know if I probably ended up writing it better than I'm explaining it now. But the point is, you get the 2L plus 1s, right? And then you get the 2L minus 1s, and then you make a 2L the difference of 2 squares times them. You get 2 to the 2L minus 1.
Wait, what? Wait, how do you do that?
What do you mean?
Okay, so let me give you an example,
I
right?
don't know what just happened.
So you have 3 equals 2 squared minus 1, yeah?
I need more space.
But
Okay.
how do you know? Okay, so are you saying if you have 2 to the small L minus 1, you get 2 to the small L plus 1?
No.
It's like if you have 2 to the L minus 1, then you get all the you like 2 to the I plus 1 for I less than L.
Yeah, exactly, yeah.
And then you use those.
Yeah, but I could just be 1 less than L, yeah?
And so like,
So
And if you
it
double
only
that,
fails
it'll go
when it's
over.
like-
Yeah, when L is like 2 or something, yeah.
Wait, hold on.
So that's what you do.
Okay.
Oh my god, is that
Okay, let's see if this is actually a proof, okay? Because I wrote this kind of in a hurry.
1 times 2 is equal
Longer
to
than
L.
that.
What's going on here?
So when L is
3 squares.
pick a card, any
5
card.
is
Okay, so if L equals 2, yeah?
Oh, that's like
Wait, let's
So if L equals 2,
just.
then that means 3 is in S, right?
Yeah, so L is 2, just 2 and 3. And 2 and 3 we know just like
So if L is 2, you get 3, right?
Uh,
And then you get 9 as well, yeah?
yeah.
And you get 5, yeah?
Yeah.
And you get 25.
Yeah.
And you get 13. And you get 7. And 7 is basically L equals 3. So then L equals 2 is the same as L equals 3.
Oh, that's a big chain. What?
Yeah, damn.
Okay. I mean, I focused on proving this lemma. That's just being I didn't think of the lemma as a greater purpose. Okay, and then you have L equals 3, right? What the hell?
Joe.
pick a card, any card.
What?
The balls.
I see you love the right.
I guess the point I'm trying to make is we do L equals 3 and L equals 2 separately, yeah?
Yeah.
Yeah.
But L equals 3, can you take your M as L?
Oh, I see.
M.
Because you like.
What's the
Yeah. So L equals 3, you have 7. 7, you get. What do you want to get?
You can get like you get
15.
2 to the
That's not
L
your card.
minus 1.
Secondary
You have
force.
2 to the L minus 1 minus 1. And you have 2 to the L minus 1.
Oh, what? Yeah.
Wait, what are you
Wait,
doing?
wait, I think so. You have. Hold on. a sec.
L 11 point.
Okay, but L equals 2. Like, you even have 15 here, right? Which is L equals 4, yeah.
Yeah. 3 times 5.
Yeah, and then if you have L equals 3, you get the 7. And 7. I don't know,
Just take 3 and 5.
yeah, 3 and 5. But L equals 3. If L equals 2, you get 3 and 5. What about L equals 3?
L equals 3, you can also take just 3 and 5. Can't you?
Oh, wait, how do you get to... Well, I mean, you can. So you start with 7 when it's L equals 3, right?
And then you take 3 and 5, and that becomes 15. Which is,
Wait, how do you get 3 and 5?
I get 3.
isn't that what we
Oh, yeah, because you got 2, and your 2 plus 1 is 3. Yeah. And you got 4, 4 plus 1 is 5. Oh, that's very good. Maybe I should write that in. Anyway, so the point is, L is greater than 3. Yeah.
Yeah.
Okay.
I'll start sealing the balls.
Okay, so then you let k equals 2 to the m, where m is less than L, right?
Okay.
And then we explain that you get 2 to the m plus 1, yeah?
Wait, how does that work?
So you make k equal to 2 to the m
Yeah.
in this lemma. Yeah?
K is less than 2 to L.
Huh?
Wait, what?
Wait,
Huh?
doesn't your lemma show?
Isn't your
Yeah,
lemma like
everything.
cyclic reasoning?
Huh?
I'm confused.
No, the lemma only shows you get k plus 1.
Yeah, so
Yeah, but if you like,
Yeah, but
you
it
let
depends
K
on-
be two.
Wait,
I think you have to have k be less than 2. Wait, wouldn't
what's going on?
Yeah.
What's going on?
If you let K
Wait, no,
be
you
3,
could
then you
probably
just get everything.
k be 3.
But you could probably prove it, but it's
Well,
like
we need k to be inside already. Though. Like we don't know if k is 3 is it already in.
well, hold on.
Well, I thought.
No, this might
Is this
work.
the end of the proof?
Oh
Or
yeah, this is like
Oh, so
nearing
he
the
never
end.
proved that 3 was in it.
Yeah, I haven't proved
No,
3's in it
that's
yet.
not- These are lemmas. These are lemmas.
Yeah.
Wait, no.
I think
yeah.
lemma 11.3 finishes well. Like if you have
Yeah.
2 and then you have some b, then there does
It is
equal to
less
the
than-
L
Yeah, my proof with lemma with 3 is the dodgiest, because I kind of did it last minute.
Hand
I
wave.
think a card
Yeah, so basically,
Well,
you get 2 to the m plus 1, right?
Oh, wait, I get it. So you're basically like going down a step, and then
Okay, so then you go all the way down to 3, yeah?
Yeah, you can see
And with
the
3, you
Seven,
get
7 or something. No.
you get 2 squared minus 1. Yeah. And then you just times this by
This is the final.
you just times this by 2 to get 2 cubed minus 2, right?
No.
And then you add 1 to get 2 cubed minus 1.
You said the whole time this is working.
Does that make sense? So you let k be 2 cubed minus 2, and you add 1, you get 2
But
cubed minus
once you get 3, don't you get everything?
once you get 3, you basically get everything.
Yeah.
I guess so, yeah. But what was the manner in which you proved that once you get 3, you got everything?
This is it's like this is in the
With
same
the
sequence,
lemma.
right? Yeah,
You just
Yeah.
use this.
So I guess I'm just saying that
you get 2 and
once you get
like,
3, you get arbitrary large 2 to the power minus 1.
Yeah, and then you get
2 to the L
arbitrary
minus 1.
Yeah.
And then you can just apply that to the first lemma, and then you get everything.
Yeah.
So he's doing a different in a different.
Yeah, so all I'm saying is that
Basically,
if you have k and it's smaller than some 2 to the L minus 1, you get k plus 1, right?
Yeah.
So if you can get 2 to the L minus 1 to be big, then you get everything.
Yeah.
And then I'm saying you can get 2 to the L minus 1 to be big by first going down to 3 and then building up. So 3 is your 2 squared minus 1, right? And you times that by 2, so you get 2 cubed minus 2. And then you plus 1, you get 2 cubed minus 1. And so then you get 2 to the m minus 1. You just keep going up. You get 2 to the m minus 1 for all the m less than L.
Oh, I see.
And then you set m to be L minus 1.
Oh, you get
sorry,
15, and then you get.
so I'm saying this.
Okay.
Bro, this difference of squares.
Wait, so you're assuming you have a 2 to the L minus 1?
Yeah. I haven't explained how I got that yet.
This difference of squares.
So I got 2 to the L minus 1, yeah?
Yeah.
And then I got 2 to the m plus 1 for m less than L, yeah? Yeah? That's just letting k equal the, that's letting k equal 2 to the m, yeah? Yeah?
Wait, so once you have 2, if you assume you have 2 to the L minus 1, why don't you just get everything below 2 to the L minus 1 straight away?
Oh, everything below. Oh, yes, you do.
Yeah, you do.
yeah,
Oh,
you
I'm
Yeah,
just
that's
being
what I'm
dumb.
saying. Like, you
Yeah.
just get everything anyway.
Oh well, I thought he knew that. Isn't that what your level?
Yeah, that's what your lemma states.
Oh no, you get everything, but I'm selecting some things that I'm getting, but but
Yeah.
I don't have to be that careful. Yeah,
Yeah, because they're all there.
I just times the bottom 2 numbers. But then and then you just need to know one of them. They're of the form 2 to the m plus 1 and 2 to the m minus 1, right?
Yeah.
Yeah. Okay. So that's good. That simplifies this a lot. So all I need now is I get 2 to the m minus 1, right?
Yeah.
Yeah. And so then I get 2 to the 2m minus 1. Yeah.
Well, just pick m as L minus 1.
Yeah, exactly.
Yeah. Okay. And then you're done. For
Yeah. But L is greater than or equal to 3 or something.
Okay, now we're going through that one.
Okay, how do we prove?
Oh, that's a
3?
good simplification.
How do we prove 3?
11.3. So if we just have 2 and we have this random number, then we must have some kind of error to it out.
Yeah.
Surely it works. That's
Surely.
So if you have 2, you basically have 2, yeah? You're assuming this,
But
Yeah.
you use the same word.
and you have like a b. You can assume b is like odd or something, right?
Yeah.
You can probably even assume that b is like 2 to the m plus. It's like a binary expansion, I guess.
Yeah.
Uh,
To the K, to the L wasn't that.
yeah, I kind of wrote it a bit funny, right?
Wait, this is lemma 3 now?
Yeah.
11.3. So you just
I'm
prove
almost
that
ashamed to
L
even
is
show this lemma here.
inside.
If 2 is in the set.
Yeah, and
And
B is
B
also in the set where B is not power 2, then 2 to L minus 1 is in the set.
No, no.
If
Yeah,
I do
so
it,
this is not even the L.
until we can see that you went
Oh,
a little bit faster in this one.
The hand wave.
Yeah, the hand waving, yeah.
This one,
The hand just started waving.
So maybe this is a good one for us to fix because
Okay.
like I was coming back to it, right? And then I was like, it's just blank. I wrote the lemmas and didn't write the proofs.
Divide by 2
And I couldn't even remember what I was doing,
until
so-
you reach a 1. And then the make odd step was a power of 2. It came from I don't understand.
So this is maybe a good exercise for us then.
This is a good exercise in trying to
I
understand.
was considering the thing as well. If you
Okay, divide by
divide into the
2 and
what you're
take
doing is actually just taking
ceiling.
the end thing off.
Take ceiling, make odd until you reach
What?
and 1. Wait.
You're taking this number like.
Oh, I see what you're saying.
Yeah, you can't.
Oh, yeah, obviously.
Okay.
Wait, no. You're not taking it off.
Yeah,
So
you're-
if you divide
Until you
by
reach 1, then make
no matter what,
No,
if
no.
if this is a 1 or 0, it doesn't matter.
so it's like if you divide this by 2 and take the ceiling, it seems like you're lowering all the powers of 2 by 1.
Yeah.
It's like what?
And that'll be a problem if like one of the powers is already close to is already close is already
L
gone.
is 1, then
No, yeah, you have to add
one
more.
was the previous.
So isn't it?
You're taking a ceiling.
Oh, this is actually pretty big.
So obviously, yeah.
Okay, yeah, this one.
Okay, let's see.
Why is this?
We should rewrite this proof.
Michael wrote this in like 15 seconds.
So this is where you have to pause it.
So 2 to the m. What kind of notation can we come up with here? 2 to the m1 plus 2 to the m2.
Oh dear. What is happening?
Okay, wait, what is this like a situation?
2 to the m sub m.
Oh god.
You get like 1, 1, 0, 0.
2 to M.
Sub r. Oh, this is just running out of letters here.
2 to sub X. MX.
No, if you have ending zeros, you can always get rid of zero.
Plus 1, yeah?
So,
Use on.
So if you divide by 2 and sealing it, right? You lower all the powers of 2 by 1, yeah? So then I guess you approach the situation where this is just 2, yeah? Because that's the only trouble case anyway.
No. This is what Daniel said. Like, are you saying you're just taking
Okay, this is a funny proof.
like you're subtracting?
I need to actually
Two
verify
slides
this.
So it's like
Hey, so it's not that fair.
I'm subtracting the index of the power, the superscript by 1 every time.
yeah. What
Yeah.
happens to the one?
So the 1, as long as the power, the last thing, if the last thing is bigger than 2,
Oh wait, this works.
Yeah, because the plus one stays. Yeah.
yeah, the plus 1 just stays,
Well, I think
right?
this works.
Yeah, see, yeah, you eventually get it too.
You get a 2, right?
Yeah.
And then you do it one more time.
Actually, I
Oh, maybe should I? Am I pushing my luck here?
One more time.
Don't do it any more time.
One more time.
One more time.
Yeah, so if you do it one more time, let's see.
Then you lose your money.
So that becomes a 1, right?
Yeah.
And then that 1 plus is a 1, right?
By 2.
So then it becomes even number again, right?
So then that's just a 1.
It ends with a
It's an even number again.
Huh?
So
But that doesn't quite work.
You, my friend, pick another cup.
I'm a little confused. What's
No,
going
no,
on?
but it ends like it has a 2, so if you divide it one more time, then it turns back into
Shuffle
a
this
1.
yeah,
I'm confused.
so then the only issue is if it turns into 1, right?
Yeah.
So if this is now a power, so you get to if this
Oh,
becomes a
then
power
L
of 2,
equals
yeah?
1. Oh, wait, I'm stupid. Okay, yeah, that's right, that's right.
Oh.
Okay.
See, this card, this is a stick of spades.
I think that's
Okay, I get it.
This is
Though.
a 5 of spades.
It's fine. I get it.
It's fine because I get it.
See
he
this
gets
card?
it. He gets it.
Oh, he gets it. He gets it. He gets it.
Let me think.
If it turns into 1, then that
I
means
think it's
all those
65.
M1s are not there.
6 of
But
5.
then-
Yeah, because if it turns into 1, that means this is not a power. This is a power of 2, right?
I don't know. It's like,
So that means it was 2 plus 1.
oh, I got it wrong.
No, wait,
No,
put me 2 to the
I said it, but oh,
Yeah, it
so-
could be. No. Wait, what are you saying? Like, what are you saying? Like, no, it can't.
So I'm saying like if this is what you started with, right?
Yeah.
Yeah. And doing this gives you that, right?
Yeah.
And that's a power of 2. The power has to be 1 as well. It has to be that 2.
Okay.
'Cause that's what you know is there, right? Then all this other stuff can't be there.
Okay.
And so then your original number that you did it to was 3.
Well, why can't the original
Oh,
be 2 to the m plus 1? Like,
Because if
you do 2 to the m plus 1, and then you get 3, right?
if you get 2 to the M plus 1, then you get 2 to the
Okay,
what?
so-
Doesn't that just keep? Oh,
You eventually get 3.
So do you,
that's 2 to the like that's eventually like
wait, can we do it in one go, you mean?
no,
Using the similar ideas? You mean like if we divide by 2 the m plus 1? M1 plus 1 or something? What are you saying?
Wait, so you're trying to show that 3. Oh, what are you even trying to show?
Me?
Yeah.
so that's 2 to
I guess-
the minus 1 is this.
Wait,
Yeah.
so if you show 3, are you done?
Yeah.
I think
Oh.
you can show that 3 exists like that.
Yeah.
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 So basically,
Wait, does this show 3 exists?
I think so. I think it does. Wait, does it?
We could come up with a better way though, I'm pretty sure. So basically this argument is like this, yeah? You take b as binary, yeah?
And then
You keep dividing by 2 and sealing it
Yeah.
until you get to the situation where it's a 2 plus 1 at the end, yeah?
Yeah.
And then you do it one more time.
Yeah.
And you'll get that's when you get to an even number, right?
yeah.
If it's not a power of 2, you can just keep going, right?
Yeah.
But so if it is a power of 2, then it has to just be 2,
Yes.
yeah? And if it is 2, then the number it came from was 3. So you would have had to have 3 to get to 2.
Oh damn.
True. That's
True.
Is that true?
And then. No, I'm pretty sure it's true.
And then getting
Oh,
3
fine.
is 2 squared minus 1. So
I think
I think this is correct.
believable. Ooh.
It seems legit, but it's not
So-
that clean.
Yeah, maybe we can clean it up.
Seriously cheat.
I think you can do some like backwards 3. Like, it's only bad if you like skip 3 and then you go straight to 1, right?
Straight to
Yeah, but how does that happen?
Wait.
I don't think- Wait, you can't go to 1. You can only go.
You can go. No, and you go from 2 to 1,
Oh wait, I'm stupid.
right?
Oh yeah, yeah. I'm delayed. I'm
It's
delayed.
bad if you got to 1.
wait, what's
So
bad?
he's saying that if you get to
this
2,
process
you
or
have to
something
come-
else?
Yeah, like if the process skips 3, basically.
Wait, but
Like,
if
it's
you get
obviously
to 4,
strictly
then you're all
decreased,
screwed.
and then
Oh yeah, okay.
it would be bad if it skips 3.
Yeah.
And then if it skips
Oh yeah, but
you
you're
have
saying
to
like
go
if
to
you make it
1.
odd, then it
Alex.
can't be.
So I'd have to go to 2 or 1. Yeah.
Well,
Can't
if
be
it goes to
4.
2, obviously it goes to 1. So it has to go to 1.
2.5.
So if it goes to 1 and skips 3, you can like do it all backwards.
No, if it goes to 1, I'm pretty sure it means that you must have started with 3.
Wait.
Yeah. 'Cause if you end up at 1,
No, if you end up at 1,
if
you
you,
have
do it, if you do it to 3, it has to go to 1. So everything ends up at 1. It's just whether you skip to 3 or not.
Wait, but you can't skip 3 because you have to make it odd. I don't think you can skip 3. Because if you ended up at 2, you're either on 3 or 4, but we're making it odd, so it's not.
oh, it's not what you're saying.
It's like, what can you make 1 and 2 with?
No, you said
Wait, why did you take it base 2?
So what can you make
I'm
2
confused.
with?
Is that in
1 with?
Am I missing something?
1 with, you can only do
I think
it by
I'm dumb.
dividing 2 by 2.
Oh wait, no.
No, it can't be.
Oh,
wait,
wait.
it is 2 by 2. So
Yeah.
to get to 2, it would have been either 4 or 3.
Wait, but what's the process you're using? Are you doing like divide by 2 ceiling,
Yeah.
and then when you get to an even number, you just take out the 2 power? Or is that what you
Which
do?
is just divide by 2 still. It's the same function. You just divide by 2 still.
Oh.
Like,
Oh.
obviously divide by 2. Yeah.
Yeah.
So if the last number is 0, divide by... You're basically shifting all these things like backwards.
And then adding like 1 if it's odd.
So you end up with just if you get to 1, it has to come from a power of 2.
Yeah, 2 specifically. If you do it like
It
one
has to
by
come
Yeah.
from 2.
And then
That's
2
kind of-
has to come from...
It has to come
2
from like
has to come from 4, right?
3 or 4.
Didn't it come from 4?
Like,
Oh, it
because
can
like
come
3
from-
divides.
No,
Yeah, and
but
obviously if it comes from 3, you're fine.
if it comes from 4,
If it comes from 4, you can add 1 plus 4.
What can 4 come from?
Wait,
it
what
can come from 8, 9. So I don't think you're. Wait, I don't think.
Wait, it can come from 9?
Yeah.
Yeah.
Is it 9
Wait, no,
5?
it comes from
It
7.
can't come from 9.
9's
That's
5.
7.
9 goes to
What?
5.
Also, it's 7 or 8.
It comes from 7 or 8.
Yeah, and 7 is fine, because you have 2 to the L minus 1. Like, it will
Yeah, and
either
then
come
it's
from
what?
2 to the L minus 1 or 2 to the L.
Wait,
Yeah.
but then if it comes
And then
from 8, then you're a little screwed up.
No, if it comes from A has to come from like 15 or 16.
16.
No, but then like you can just keep doing that. Wait, but how do you end that process of
No,
infinite?
you don't end it. It's just.
What the hell?
It's
What do you mean?
No,
you
no,
don't
no,
It's
end
just
it?
no matter what situation
Like-
you are gonna have to.
Yeah.
you
You're
have
gonna get to a point where you hit B,
Oh.
and then like you obviously can't go past B.
Oh yeah, okay, that's true. And
So
then
B
B is like
had to
odd.
be, D had to be,
Okay, it's odd.
and you get a
so
contradiction.
these-
Use the convention.
Look at that one.
This sounds like this sounds kind of like more what I was thinking originally. And that's the motivation for 2L minus 1. It's because it's like it's only gonna die from a power of 2, right?
Bro, why is this?
And a power of 2
problem
comes
so
from 2L
hard?
minus
I don't
1.
like this. This is my
Yeah.
first ASC.
Alright, so how do you have a write up for this? Like, propose the write up. What do we say?
If you like the
Okay, what do you say?
go deal.
What do you say?
Okay, you just say what you said.
Okay, so if we begin at our number B and keep applying the functions y by 2 ceiling,
Okay.
If it doesn't reach 3, then it means B itself is the form to L minus 1.
yeah, no, I think it's better to phrase it as you will eventually hit 1 because it's strictly decreasing.
Yeah, so it's strictly decreasing.
You're gonna go like backwards.
1
Yeah,
can...
you always hit 1. You don't have to actually
Okay,
say
so
you
1
don't
is an example of 2 to the something.
So eventually,
To reach 2 to the
You'll hit
something, you
1.
can either come from
And to
2
get
to the plus 1 or that.
1 had to come from
That's 1.
2.
Get to 1,
Had to
yeah.
come from 2.
Does it come from
One has
2 to
to
the
get-
L? Or the immediately
Yeah,
previous
like
step?
immediately it has to come from 2.
it has to go from 2.
Okay, so any power of
And then-
2 has to come from like the
Yeah,
next
you can-
power or 1 less than that.
Yeah, the
1 less than
lemma
that
is-
by the other
I think
lemma
it's
will
better to
not.
phrase.
But
No,
if
it's
it's
better to
still
phrase
that
it.
power of
Ah,
2,
yeah.
then we can keep going.
No,
But
because
eventually
you have to talk
we
about all the
reach
powers
B.
like 2 to L.
So,
Like you're assuming you skipped all the 2 to L minus 1. You can't just say you only skipped 3.
No, but if your B isn't the form of to L minus 1, then you will have to hit.
Okay, so you eventually get to 1, which came from 2, yeah?
Yeah, you can go backwards, you don't have to. You can go like 1, 2, 4, and then you can go 7.
No, then that means B is a form 2 to L minus 1. I'm saying it's either you hit 3 or your B is 2 to L minus 1.
But that doesn't mean your B still almost fun, right? Because you go like 1, 2, 4, 7, 14. Your B could be 14. Okay,
Oh,
anyway.
no, your B would hit a 2 to L minus 1. That's
Yeah, that's what I'm saying. You're saying it, which is true. Okay, anyway. So
Yeah.
1 has to come from 2,
Yeah.
and then 11 is like 2 to the n and must come from 2 to the n plus 1 or 2 to the n plus 1 minus 1.
Oh. Oh.
Yeah.
He reveals his hand right now.
Wait, he actually stated it rigorous. Okay, you literally said that, but he didn't use
Yeah, but I didn't use the mathematical notation.
Yeah, but you could have just wrote that.
Yeah, but I never use the mathematical rotation.
The notation because I don't like it.
Wait, we're saying generally 2 to the
Yeah,
n.
2 to the n must come from 2 to the n plus 1 or 2 to the n plus 1 minus 1. Yeah. And obviously, if we are doing minus 1, then we are done. But if it's 2 to the n plus 1, we can continue the process with the same reasoning. Well, I mean, it's trivial to just think about it.
If it came from 3, then...
Yeah, it's like a pretty clear function, I
If it
guess.
came from
Yeah,
3, we're
right.
happy.
Divided by 2. Like, if it's bigger than that, it'll be bigger. If it's smaller than that, it's smaller.
We don't even have to let B be odd or anything, eh?
No. No.
Alright, consider the sequence.
No, but we need B not to be a power.
2 to the L minus 1. Oh, yeah, it can't be 2 to the L.
Yeah, so that's still covered by notation.
Notation.
Wow. There's a lot of convection currents.
Yes.
Hey, look,
These convection currents look
Is this
quite
where
nice.
tornadoes happen?
What do you looking at?
There's like blue arrows and
Oh.
red arrows. This is where like
nice clear blue
this is where
sky.
you have like
So the blue arrows go.
No, that's just the current, isn't it? Like, how
The wind
the
current.
oh, it's water.
That's just
I'm
like
pretty sure
water.
that's wind. Red is wind.
What is
Let's check the breaker line.
Okay.
Oh, I thought it was the temperature.
Where's the breaker line?
No, let's just look at this legend.
Suppose
No, it is current. This is the water current.
B.
Yeah, warm current, cold current.
Oh, that could be the wind.
Wait,
or
that's
the
wind.
water.
Yeah, that could be wind as well.
Bro, check
the
for
legend.
No, I thought you have
Yeah,
to
there
current,
is.
warm current.
Yeah, that's warm and
It will
cold.
happen. It will affect the sea anyway.
Probably. Yeah.
Or 2, yeah.
Breaker line.
Wow, we get warm current, cold current. That
Why is there so
creates
much current
a
here?
difference in temperature. Wow. Yeah,
Open environmental science, hardest concept.
Define.
I think that's the only thing I took away from the geography. Because that's
most difficult science Olympiad.
There's nothing else.
That's what you even freaking want
Yeah,
to
I remember Melbourne. It's a very, urban kind of very nice, artistic city. I had to, look for my what do you call it again?
Geography.
No, geography. What was it? Livability. Yes.
Oh.
I got like
Simply by
I got 16
B.
out of
I did
20
for
and I
like
got
year
a
9 or something.
naught equals B
Yeah, here. You go here, Russia.
and
Go
B
here.
Basically, if
And-
it's not in America or Europe or Australia, then
Yeah,
equals. How do you do the ceiling?
Okay, honestly, if you're doing it right now, you would be
right now.
a little
Because
concerned.
it's a bit. No.
You don't every 60 seconds.
Africa is just bad.
The Palestinians are going for your throat, man.
Yeah.
Africa and South America is pretty bad.
$5
Recent
And that's
restart.
$5. But this is the
The white land.
White land.
No, here, gold.
Imagine you spawn in Greenland.
Reset.
You just spawn with the
Wait,
penguins.
where's the resetter was
Life
It's spawning right here or something, bro.
Bro decided to live on the hardcore.
Greenland is not it.
Spawn in Chicago, bro. You're already dead.
In Detroit.
You
it's-
support in the middle of Sahara Desert.
Africa, South America, and Greenland are like
Bro,
the
it's
best
really. Oh, I thought it was like Pacific
Search
Islands.
primate.
Hawaii is not over there.
Okay, then that's like ours now. That's
Guys,
not.
I think it's even out.
You see like Samoa? You see Samoa? That's China's bro.
Samoa.
You see old China, bro.
Oh, what the?
Oh,
Oh my god, the
no, no,
Samoan
no.
Super Sub, bro. Do you remember that from
Imagine
Handball
getting,
Heroes?
imagine being spawned here.
You be in the middle of nowhere.
New Zealand.
Man, it's
Bro,
not even.
spawns, accidentally spawns in the ocean.
Yeah, imagine if we spawn here in the
Also,
ocean, bro.
Two
That's
to
really
the L.
unfortunate.
If you spawn, like you had to spawn with reset. You didn't just
No, so your parents will take you a plane over the
and then you get burnt. They usually just insta dead. Bro.
Imagine spawning here.
There's been a glitch.
So the previous term must be 2 to the L plus 1.
L plus 1
Or
2 to the L plus 1 minus 1.
2 to the L.
Bro, imagine spawning here.
Wait, 2 to the L plus 1 minus 1.
Yeah, the whole thing minus.
And then you're just like,
Yeah, just
your,
one
your
less than
girlfriend is
the
a
L.
boy.
Like that? Is that alright?
Clearly that's
For real, for real.
Wait, where's Iceland?
Iceland, are you
Trivial.
Clearly that's true.
Iceland?
Iceland's the place with the good. Iceland's the good place, and then Greenland's the bad place.
Yeah, Greenland's bad.
They're trying to bait people.
Yeah, they actually baited them.
Iceland, Greenland.
Imagine,
Iceland is more.
No, this is Denmark. This is Denmark.
This is full of ice. This is full of
imagine
ice.
living in a Scandinavian continent here, bro.
Oh yeah.
Okay,
I
so
remember the other countries. NSF. Oh,
this notation actually looking pretty good.
NSFW. That's See, you have Norway and you have Sweden.
What does that stand for? That's
Not safe.
Not
for
safe
work.
Oh, I didn't know that.
Oh, yeah, I didn't know.
No,
Did
no,
you ever-
no,
That's why I was taking all those
I didn't know what it was meant. I didn't know what NSFW meant. I bought the card pack that had NSFW in it.
Right.
That was pretty.
Like if you watch like
Oh, let
something
me
on a
delete
very
this other
sketchy
stuff.
website, you get like really weird ads, you know? It's like I don't know.
1, 2, 3 movies.
Hot women in your area.
Classic
Single.
hot woman in your area. 31 something is single or something.
Wait, what's Seedot?
Play now.
Play now.
You name
I'm just saying, this is
Yeah,
top
that's
4
not
spawns right
second
here,
option,
bro. That's unlucky.
Like $3.
Okay, do a card.
Once you get there,
Okay.
soft lock yourself.
I feel like anywhere in the Middle East,
Hard
anywhere in the Middle East, that's not really,
Because like you need those
bad
spots.
spawn.
Anyway, after all Middle East. Apart from maybe something.
Bro, Africa, that's such a bad spawn, bro. Where's the water? Wait, drinking seawater, just for real, for real.
What if you're in the middle of Africa? It's so hard.
Shut up, bro.
Dry place. This is the dry place. There's like what? Yeah, this is the dry place.
Okay, imagine if you spawned in a country named after
Take
yourself.
a random
Bro. That's a
card.
bit weird.
It's the effort.
Yeah, that's a bit weird, right?
Okay, put on the table. Okay, I will now take.
Morocco's close to Europe, so it's not too bad. I
Yeah,
guess.
you know.
Imagine spawning in Portugal. That's
Okay,
not
okay, I think I
spawning
know.
in
Portugal.
Bro, imagine spawning in here. What happens to your?
Yes, Oh, and your food will die.
Your team will be spawning your
You'll be your first meal in the USA.
POV, you tried to sign up for this sketchy website. You see
Brazil.
email
Brazil is
account,
fine.
and it says
Perfectly
account
fine.
already registered.
Alright. Perfectly fine.
No.
Everything else not fine.
Try for all the.
This is fine. This is fine. This is perfect. Like, very
You
satisfying.
sign up. Let's go even
I know you. Okay, why would you use the school email? That's like.
Actually, that's true. Everyone would use their own private email.
Wait, 1 always comes from 2, right?
The dangerous place is the most safest place.
Oh, one comes from.
That's usually true.
2 or what?
Oh, yeah, I can say one.
Yeah, no one is no unexpected here.
Yeah, one comes from
I
two,
think
two
so.
comes from
Imagine
Matthew.
the-
This is also pretty shit.
I see, okay.
Yeah, but yeah, it comes from two, yeah.
The one can only
Are you sure they don't just use branded?
Oh yeah, we could.
Damn, I might do that for like every like friend I have right now. Oh, I should try it.
Or the emails.
Like, you just say that. Like eventually you have to reach one less than a. Eventually you'll have to take the part that isn't the power of 2 because it reaches 1. So it doesn't like.
Let's do another magic trick.
And if you click like okay, and it says this email is already registered,
It's not a
and
power of 2.
Login using unusable.
So the next person who tries.
Eventually,
No, how do you go to you send you register
send
using
number.
unused account and says account already registered.
Like, if
Figure
it's
out
2
the
to the
power.
L minus 1, you're done.
Hmm.
If it ever reaches 2 to the L minus 1, you're done.
Yeah, but it has to.
And
It has to
I think
eventually
it's-
do it.
I think it's-
Yeah, and it
Yeah.
also can't keep
Oh my
going.
god, how did he get it? Oh my god, look at it go!
I'll give you one more try.
Since B is not a power of 2, this process can't.
not Jack.
This reasoning can't happen.
It can't stay non. It can't stay power 2.
Okay, yeah. It didn't work that time. My brain has got
We gave you 2 chances.
What are the chances of 2? Like 2 out of 13. I think 1 in 6.5.
You flop.
Says you.
Wow.
All right, let's see what it looks like so far.
Okay, and then
Magic 7, magic
thus
trick.
we get 3.
Recompile.
It was
Oh,
just
no,
a
that's to
magic,
get
it only
2 to the
works
L
1 out of
minus
52
1.
times, but it's just-
It's not necessarily.
Okay, so
Yeah.
suppose B is in S not generated by 2. Define a sequence recursively with B not equals B and Bn plus 1 equals that. No?
Yes, sure.
So every
Latex
time you
makes
do
it look nice,
there's
doesn't
something-
Yeah. Latex makes it look elegant.
We showed this sequence has the property that if 2 to the L is in the sequence, the previous term must be 2 to the L plus 1 or 2 to the L plus 1 minus 1.
Let me guess again.
Now, assuming that the sequence eventually reaches 1,
You know this
Oh,
pattern?
you should.
let's say for the first time.
For the first time, yeah. Otherwise, no.
You can just say
Yeah,
the
yeah.
sequence terminates when it reaches 1.
Yeah.
Yeah.
Oh, yeah,
Okay,
technical.
Well, that's-
kidding.
That's like the
Like,
most.
has to happen.
That's, yeah.
Okay, and then 1 has to come from 2.
Yeah.
Oh.
Actually,
Yes. Yes.
We'll
Okay,
start
I know.
with funny.
Yeah, we should
it's
probably
space
prove that
house.
as part of the previous statement. 1 either comes from 1 or 2. But that's just a special case when L is equal to 0, I guess.
Yeah.
You got that scammer.
And so,
Come on.
No, he was guessing all the cards in the deck, right? I was like, what? How is he doing that?
Yeah.
He used a pin, and you in the corner with symbols. So that you can
Wait, all the cards?
all the cards, yeah, all of them. I was like,
Okay.
what is it? I look
so
carefully.
if it's
How long did it take?
if it's 2, then 2 comes from either
Wait, let me see.
2 squared or 2 squared minus 1.
Where?
And if it's 2 squared minus 1, you're
Now,
done.
like,
So you assume
how
it's
he
2
does it,
squared,
it's
and
like
it's
the
either
corner,
2
you see.
cubed
So
or
he,
2 cubed minus 1.
He like assigned the
You
corner
keep,
to one
and then you
of
keep
them.
going until
Wait, bro, the time you
B,
find
like,
it on
because
Google
B is not a
Docs,
power of 2, you're forced to make a
Oh
decision.
my god.
Like
Yeah,
you,
you
you,
can't
you,
just
you
keep
can't
going.
you can't keep getting power of 2.
How do you know for this one?
At some point, you have
How
to
do you know what
choose
sign
Yeah.
choose the L.
At some point
Okay,
before
pick any card
the
and play
start
it.
of the sequence.
At some point.
Wait, what is it?
This is 8 of diamonds.
That's his
What?
STD.
Why don't you just mod 13?
All right, so that's a proof then, right?
And there's no other
Oh,
lock, so it has to
It's
be
like
diamonds.
the Kazakhstan question.
Huh?
It's like some other people looking at that paper next to you.
Fucking
Like
Yeah.
different countries see this paper and
This
be
is
like,
double
what?
dots and this is
This is Jack. Okay, where's the
one. No,
Is that
it's
one?
one. No, there's one there and one here.
Oh, that's small joker.
Oh.
All right.
He devised this like just then. I didn't know. What is this?
How did he have time to